share. So today's webinar will be about marine applications in the WEkEO DS. And we have a very nice lineup of speakers here with us today, from both Mercator Océan and from UMETSAT. So Fabrice Messel is a marine expert at Mercator Océan, where he, where he's been developing partnerships and projects in the frame of the outreach activities related to the Copernicus Marine Environment Monitoring Service, where he's also currently in charge of the training for that service. And then we also have Haley Evers-King, who works at UMETSAT as a marine applications expert, supporting marine user engagement and training with a focus on Copernicus and the Sentinel-3 and 6 missions, which can be found in the WEkEO DS. And then from the WEkEO user support side, you have Amin, who is a technical expert and deals with all of the issues from the users. And then myself, I will be guiding you through this webinar today. I see you don't. Okay. So on the agenda today, we'll start with a brief introduction to the WEkEO DS, the infrastructure, the data that you can find, the pricing to use the platform, before we go over to a presentation by Fabrice on unique features of WEkEO for marine applications, and a demonstration of how to develop marine applications in the WEkEO DS. We will end with a Q&A session, just so you're aware. If you have any questions throughout the session, you can always ask them in the chat. There will be there's a question mark that you can put next to the question that you're going to ask, so that we see whether it's a question or it's a remark that you want to share. And then at the end, we can take out the questions that haven't been answered in the chat yet and show them on the screen and answer your questions live. If, of course, you have any questions left at the end, we are always available on the web portal, on Twitter at WEkEODS, and through our service desk email, support@wekeo.eu. But now we will go over to the next speaker. Haley, to give an introduction to the WEkEO DS.
Thank you, Anne-Catherine.
Okay, hi.
If I can get my slide. Okay, I think we're there. Hey, good morning, everybody, and welcome to this webinar today. I'm Haley, as Anne-Catherine so nicely introduced. Thank you very much. You'll see me twice today. This is the first of one of the talks that I'm going to give.
Haley, we can't hear you anymore. Seems like we have a little bug in the system. Hello, Haley?
Can you hear me?
Ah, yes. Hi.
Okay, that's right. Just let me know if it breaks up again. Hopefully
Okay.
It will hold. It's hard for me to tell if it's broken up or not. Yes, I'll come back at the end of the webinar today to also show you a more in-depth example of one of our marine applications workflows in WEkEO and talk about how you can start developing your own. So WEkEO is a partnership is a partnership between us at EUMETSAT, ECMWF, and the European Environment Agency and Mercator Ocean International, where Fabrice comes from. And we have the WEkEO platform being built under the Copernicus program, which is part of the European Commission. And with WEkEO, we really have this kind of federated approach between all the different entities where we're joining up our experience, our skills. We all run different parts of the Copernicus program anyway, in terms of satellite operations, deriving the data and delivering it to users. And so we're really trying to capitalize on all that experience and knowledge that we have there, working then with the industry to build what is effectively a cloud processing platform for you to access Copernicus data and work with it. So what is WEkEO? It's a partnership, as I mentioned, between these four entities, and on it you can access all of the Copernicus data. So this is the data from the Sentinel series of satellites, as well as the downstream data that comes from these satellites, from models and from in situ parts of the program through the Copernicus services. And there we have atmosphere, marine, land, climate change, and emergency service data. As well as the data, you have a whole load of services and high levels of support from WEkEO. So part of WEkEO is infrastructure in terms of providing computing resources, some of which you'll see more about today. Different tools to help you work with the data. Development and management support, and expertise from people like myself and Fabrice, Amin, and our other colleagues across the institutions who can provide advice on both how to use the data and how it works, as well as the technical support you might need for working with the infrastructure. We're also working to develop more services, such as a marketplace where you can share what you've done in WEkEO with the outside world if you're developing, for example, a small business around what you're doing with the data. WEkEO importantly offers a single point of access to all Copernicus data. If you've worked with the data so far, you'll know that you can get it from various different places, depending on who's operating the satellite or who's creating the data through the services, for example. But through WEkEO, you have a single point of access. We have an API that you can use to access all the data through one platform, which hopefully makes things a little bit simpler for you as a user. We offer cloud-based hosted processing and different tools. So this includes things like virtual machines, but also the Jupyter Lab environment that you'll see later. And as I mentioned before, kind of one of the really strong assets I think that we have here at WEkEO is this expertise that's built from the different entities that are involved in running WEkEO. So across EUMETSAT, ECMWF, Mercator Ocean, and the Environment Agency. The data that we work with is a copy. So through the Harmonized Data Access API, you're able to access data directly from its original sources. This should mean that you don't have any problems with data being older and not being the latest version, for example, and also connected very intimately then to the data and documentation directly from the providers themselves. We have this expert user support, which can help guide you to find the right product for your applications and answer any questions you have about how those products work, as well as the infrastructure that we provide. And all of this is accessed through the Harmonized Data Access API. This is really very central to what we do at WEkEO and how you access the data. And we'll show you later on how you can actually use this in different ways. You can do it through both a browser interface and through programmatically. So we'll show you some examples of doing this through Python as well. Who are the users we have at WEkEO? A wide range, different people within the European member states, public services, research entities, and the private sector, as well as just interested members of the general public. Really, it doesn't matter what sort of user you are, there's something that we can offer you at WEkEO. And you are very welcome to join us. So if you haven't already, please visit the website. This is wekeo.eu. You can register there to access trial environments and some of the free parts of our offer. You can follow us on Twitter, and you can also contact us through the support desk. Thank you very much. And I'll hand back to Anne-Catherine.
Thank you, Haley, for this introduction to the WEkEO DS. We will then continue with Amin, who is going to talk more about the IT infrastructure and that is offered by the WEkEO DS and the pricing for if you want to use the WEkEO DS. Amin?
Yes, thank you, Anne-Catherine. So good morning, everyone. So my name is Amin. I am part of the support team of WEkEO. I am going to do a brief presentation of the IT infrastructure of WEkEO, which consists of two main services, the Jupyter environment on one hand and the virtual machine. So it's been a few months that our new Wekeo website is active now. So as you can see, we have this more intuitive design. There is a documentation section that has been revisited, and so do not hesitate to take a look at the documentation section and this new FAQ before sending us a message, because you might find some of your answers there. So let's start with the Jupyter Notebook. All you need to do to have access to a Jupyter Notebook is to register to Wekeo. So it is a free service on Wekeo. I already have an account, so I will sign in. And once it's done, you can click on the dashboard button here. Then on Jupyter Hub here. So you will have access after a few seconds to an interface like this, which is the welcome page of the Wekeo Jupyter environment. So what is this Jupyter environment? It's an open source web app that you can use to create and share documents that contain live code, equations, visualizations, and text. And you have, through this launcher, access to a classic Python interpreter and a terminal prompt that allows you to browse through your Jupyter environment, because it is a small virtual machine environment. That's what it is. And you can also create documents from scratch or play an existing file, which you will most certainly do in the webinars and trainings. So this Jupyter environment is a very useful teaching tool, as code is associated to text and images. And a typical Jupyter notebook would be this Wekeo harmonized data access that I will show you. So you click on the public folder, then Wekeo HDA, and you have this already prepared document that is very useful, because as you can see, it is a typical Jupyter notebook. It contains images like this, text, and also some code. So you have this these code cells that can be run exactly the same way as on a Python interpreter. You can execute them. You can execute them by clicking the play button here, and it will run the cell one line after the other as any other Python interpreter. The outcomes and results of the code running are actually displayed in the document itself. And for example, you have graphs. If you are drawing graphs out of the Wekeo data that you have downloaded, you can show them here. So I don't have time to go into details, but in this piece of code, in this cell, for example, by reading the document, you will understand that you can copy the HDA request, the description of your request, actually, and the code encapsulated in the Python functions used here will allow you to target a certain number of products of interest, and these products will be downloaded using other functions in the following code cells later in the document, as you can see. So this is just one of the many introductory documents that contain educational instructions that will be presented by numerous experts on different topics through the webinars. And getting familiar with these documents will make you comfortable with the Jupyter environment very, very quickly. So last thing maybe about the Jupyter environment, note that these documents can be exported to PDF or to pure Python code to be used elsewhere by running the code, for example, on a virtual machine. So this brings us to the virtual machines. Some of you might ask, why would we need a virtual machine environment? Isn't the Jupyter environment enough? But the thing is, Jupyter notebooks are limited. The environment is limited. It's not meant for advanced processing, resource-demanding processing. The storage capacity is limited. CPU and memory are also limited. So it's ideal for testing and mingling with data, but it's not meant for heavier processing. So if you want to perform some heavy processing, so to speak, consider switching to one of our virtual machines. And Wekeo has this virtual machine offer. And to profit from it, you can go to the dashboard again. And at the end of the page, you have this upgrade plan button here. Once you click, you can fill some information that we might need. Also, this plan size, so it's the size of the resources of the virtual machine that you want to ask for. And you have this small table at the end of the page that indicates the configuration of each plan that is listed in the plan size here. But we have also this pricing section here that contains a wider table with all the configurations that you might need to know. And each plan size has a different pricing, obviously, but there is a trial period that is available. The smaller the plan, the longer the trial period available. And note that these trial periods are indicators only, so they can be negotiated on a case-by-case basis, as long as you send us a message to support@wekeo.eu, support@wekeo.eu, and we will put you in contact with the commercial department of Wekeo. So once this resource is made available for you, we advise you to follow the guides to create instances of the virtual machine. So the guides are available in the docs section. And you have this virtual machine title here. If you follow all or some of the articles that you will find here, you will be able to create what we call an instance of the virtual machine. So it is as if as if you were on your personal computer. You can process your data, and with this large computing capacity and high-speed access to Wekio data that is offered by Wekio. So if you have any questions about this, I would refer you to the webinar number 3. It's available on the Wekio YouTube channel, where there is a demo on how to download Wekio data on your Jupyter Hub and on your VM. So I think that's all for me. I pass it over to Anne-Catherine, and thank you very much.
Thank you, Amin, for showing us the infrastructure available on the Wekio DS. So I will be showing you very quickly just which kind of data you can find in the Wekio data catalog. As it's already been mentioned before, there are 235 datasets available in the catalog on the Wekio DS, which you can browse freely in the viewer that's available on the website. So you can already have a look at what data are available, what do they look like, where can I cover the area that I'm interested in. All of that you can see in the viewer. And so in terms of which datasets you can find, we of course have the Copernicus Marine Environment Monitoring Service data, which you will learn more about today, the specific applications. But then in addition to that, if you're looking to expand on your application, you also have the Atmosphere Monitoring Service data, the Climate Change Service data, Land Monitoring Service data, as well as satellite data from the Sentinel 1, 2, 3, 5P and 6 has just been being made available, data available. And so what you can do with those with these data will be shown by Fabrice and Haley in just a little bit. Just so you are aware, if you want to understand better on how you can access the data, please do make sure we just want to say that there is a Wekeo YouTube page where you can find a lot of information tutorials already available for you to get started if you have any questions or want some more support after this webinar. But then I will now pass the floor to Fabrice to show more about the marine applications. Good morning.
Good morning. Thank you, Anne-Catherine. Hello, everyone. So it's quite challenging to show you the entire data available for marine applications, but let's try to share the maximum of information with you today. So as Anne-Catherine showed you, we have different catalogs which are available on WEkEO, and you can have access to a large amount of data, of marine data through the Copernicus Marine Service catalog and also the EUMETSAT Sentinel-3 catalog. But in many domains, you need more than marine data to make marine applications. For example, if you work on coastal management, you need land data. If you work on climate, you need atmospheric data. So this is the power of this platform. You have access to different portfolios, different catalogs, and you can mix all this data for your marine application. Let's go to through the Copernicus Marine Service catalog available. So you have access to 145 data sets from 3 different sources. This is very important to know that you have access to satellite data, but also in situ data and model data, because you can build different applications, because the different data have different resolutions, different temporal coverage, spatial coverage, depth. So you can choose which relevant product you need to build your own marine application. So this is a very diverse products, a very diverse catalog of products through the Copernicus Marine Service. And then through the Sentinel-3 catalog, you can have also access to satellite data, altimetry, ocean color, sea surface temperature, and atmospheric composition. So thanks to this, you should be able to build your marine application, and we hope to make our maximum, our best effort to allows you that. And one thing more, it's we try to provide you access to the data, but not only the data, but computational resources, as Amin mentioned, to build all your codes and applications and informations through a visualization tool. We try to address all the needs from different communities. So it's very important for us to do that. And it's not only a catalog of data, okay? So through this, with this software, we want to address the main sectors of the blue economy. So we have different sectors like polar environment monitoring, climate, ocean health, marine conservation, biodiversity, science, policy and ocean governance, education, hazards and safety, marine food with fisheries and aquaculture, coastal services, marine navigation, marine renewable energy. And we try to group this all these sectors in 3 main themes, which are environment, society, and economy. And for each of these themes, we try to give you the best support we can with our data and our platform. So for the environment, what kind of activities you will do in this sector? So you have to create regular reports, you have to conduct studies to monitor the evolution of the environment. And thanks to the catalog and the offer of WEkEO, you will find variables, so sea ice, temperature, sea level, nutrients, salinity, etc. with, as I said before, 3 different kind of sources with long time series, forecast, 3D data, but also computational resources, which is very important, and code sharing. This is very important for people who are not aware about coding or they don't have the resources, available resources to build their own application. So it's very important. And when I talk about code sharing, you will see with later with Hailey, we have a lot of Jupyter notebooks on our GitHub, and for example, on marine heatwaves or cyanobacteria monitoring. So it's very important for us also to share expertise. On the society, again, you will have to create reports, conduct studies, raising the public awareness, make prediction, implement the European directives. So to do that, we try to, again, provide all this information, and the harmonized data access is very important also for people who don't know really how to access the data. They want to, we want to simplify the access and facilitate the access to the information through this kind of IPA and again, the computational resources. Last sector, economy, you need to monitor the environment, you need to protect your activities, optimize the navigation of your ships, estimate the marine renewable energy potential of different areas. So it's very important for you to have access to forecast, again, a long time series to characterize sites, and you need an operational platform, and we give access to this function. We are operational 24 hours, 7 days. You can access the data without any trouble, we hope. And for example, I would like to share with you 2 use cases. One is Marine Analyst. So the Marine Analyst is a novel platform for searching, viewing, and processing also marine spatial data from numerous data sources, because you have not only data from Copernicus Marine Service or EUMETSAT, but also EMONET, for example. And this platform is powered by WEkEO, and you can generate on-demand data analysis for any locations. And the platform allows to address challenges like maritime spatial planning, climate change, marine protected areas. It's very simple. By default, you have a library of illustration, maps, graphics already prepared, and you have just to compose your own bulletin, so your own report, and you can launch this report each time you need. So it's very simple. And the second use case I would like to share with you is Coverage. So Coverage is developed by NASA Jet Propulsion Laboratory. It's a platform to simplify and expand the accessibility and usage of satellite and in-situ data. And the intent of Coverage is to help emerging user communities with less expertise working on the Earth observation data. So the idea is to provide information from different platforms and to collect all this information with added value products from different sites, from, for example, FAO in the thematic demonstration application about ICES tuna fisheries in relation to environment. So you can go on the website to have a look to this two use cases. Again, all these 2 use cases are developed on WEkEO and are running on the WEkEO platform. And don't hesitate, if you have a use case you want to share with us, you share with all the other users. You can send an email to support@WEkEO and share your usage of the WEkEO platform with us. Thank you very much.
Thank you, Fabrice. We will, after this inspiring presentation, we will pass over to Haley, who's going to give a demonstration on how to practically implement these use cases or other marine use cases in the WEkEO DS. You're on mute.
Okay. Thank you, Anne-Catherine.
Yes.
Can you hear me okay? Good. Perfect. Okay. Thank you, everybody, and thank you, Fabrice and Amin, for giving me a really good introduction there to some of the things that I will show you in practical use during this demonstration. I'm going to start just with a few slides, and then we'll move into the live environment on WEkEO, showing both the website portal interface and the some more detail on the Jupyter lab that Amin's already shown you part of. But just to recap, as Fabrice mentioned really excellently there, we have a whole range of data available through Copernicus and therefore through WEkEO for a wide range of different marine applications. From the satellite perspective, altimetry and star data, sea surface temperature and ocean color can be combined together, and with model and in situ data from Copernicus for a huge range of marine applications. Pretty much if there is a marine relevant application that you're working on, the chances are we have some data that could contribute to it. So this is just to give you a bit of an idea to start thinking about how you might apply the data that we have to the different challenges that you're working on. And you can also ask us questions about this both during this webinar and afterwards. So in terms of working with marine data in WEkEO, there are several ways. You can use our data portal, which I'll show you a bit more about in the demo, to start accessing the data and having a bit of a look at it. This will also lead you nicely then into using the data in a more large-scale programmatic fashion, where you can access the data using code that's available in Python. We have some examples that we'll show you more of in a minute. This code will work both locally, so you can download it for use on your own computer and interface with WEkEO. But if you use it within the WEkEO system, either on our Jupyter Hub or the virtual machines, you'll get much faster access to all the data, as well as the remote computing resources. So you won't be using your own laptop, you'll be using the facilities that we have in our infrastructure. To get started, Amin already mentioned there are some very basic notebooks that can help you with the Jupyter environment and explain the harmonized data access. So you'll see these in a minute, but just so you've got these for reference, you'll get this presentation later. There's two notebooks welcoming you to the Jupyter Lab environment, which tells you how it works and how to run it, and one on how to use the harmonized data access in basic principle. You also see there's lots of examples across the different thematic domains that make use of the same functions here to access the harmonized data access, because it really underpins all the different applications that we have available to show you. In terms of then marine specifics, there are two folders in the WEkEO Jupyter Lab that will allow you to look at marine data. One on Sentinel-3, which gives you basic introductions to the data that's available from the ocean color, sea surface temperature, and altimetry packages aboard this mission. And then there are some ocean case studies. These include both the Sentinel-3 data and data from Cmems, as Fabrice discussed. So you can have a look under that folder, and I will show you one of these in much more detail shortly. So when you're thinking about setting up your workflow, I've got a couple of questions here to help you kind of think about what it is you might need from WEkEO and how you might need to access it and what tools you might need to build the workflow that you want to work on. So one of the first things to ask is, what data do you need? And this depends very much on the type of application you have. So think about the variables of interest, whether you might need chlorophyll, sea surface temperature, wave, wind information, etc. Think about as well the resolution you might need this data at. Normally there's multiple sources of different variables, whether you're looking at the satellite data directly, model data, or in situ data, but your application will determine whether you need that data at a higher or medium spatial resolution, what coverage you might need, how often you might need the satellites to be coming over in order to adequately capture a phenomena that you're wanting to look at, or how long you might need a time series if you're doing a more climatic scale analysis, for example. There may also be some things to consider with regards to the ins and outs of the specific sensors, so what their spectral resolution and sensitivity are, particularly for optical missions such as Sentinel-3 and also Sentinel-2. You'll also need to think a little bit about what the assumptions are for your application. We have different data sets that have been processed in slightly different ways to support different applications. An example of this would be the sea surface temperature products that we provide. Some are more suitable for looking at long-term climatic trends, and some are more suitable for looking at high resolution, like features at a sort of an event scale basis. And so depending on what you choose, what you have in terms of application, you might choose different data sets to meet your needs. Then you need to think a little bit about how do you want to analyze the data. Do you need to apply certain methods to extract certain bits of information that you might want to answer the questions that you have, and how do you need to visualize it? Do you need to provide images? Do you need to provide plots of some kind? This will influence what sort of tools you might choose to use either in the virtual machine environment or in Jupyter, which has access then to all the different libraries that Python provides. So just to give you an example of how this works with the workflow that I'm going to present to you today, I wanted to look at marine heat waves. So this is a phenomena that occurs throughout the global oceans where we have, just like on land, periods of higher than average temperatures for a certain amount of time. And these phenomena can be particularly damaging to any organisms in our oceans that suffer through thermal stress, most notably things like coral reefs, but also other species as well. So if I want to look at these, we're talking about thermal stress. So obviously one of the things that I might want to work with would be temperature. So sea surface temperature data would be a variable that I'm interested in. In terms of resolution, heat waves are something that happens at an event scale. So they might happen for days to months, and they might be happening now, or I might be wanting to look at one in the past. So I actually probably need a bit of both in terms of the types of data. I might be looking for event scale information, but also maybe a longer time series at a climate scale. Assumptions I might make, I probably want quite high quality climate level information if I'm looking over a long time series. So I might need to have data over many years that's been intercalibrated and that is robust over a long time period. So I can look at trends, for example. In terms of analyzing the data, perhaps I might want an index. So I might want to know, is a marine heat wave happening now? How long has it been happening for? I might need to quantify that through thresholds, for example, or something like that. I might also want to look at trend analysis. So I might need some statistical methods to use. And in terms of visualizing data, I might want to make a map to see the extent of the heat wave in space. I might want to look at time series to look at how heat waves have happened through time. And I might actually want to develop some simpler end graphics for your users. If somebody who is working, for example, with coral health is interested in this work, they might need simpler kind of graphics that explain when heat waves have happened through time to express the issue to policymakers or the general public. So they might not want super technical sort of scientific information. They might want something that's easier for people to digest. Instead of looking at all the complex information. So this is how I was thinking about the marine heat wave application. And I'm going to show you what that has practically looked like in terms of my use of WEkEO. So I'm going to change from presentation to screen share. Okay. And hopefully now you can see my screen. So you've seen before in previous presentations, this is the WEkEO web page, and we have our dashboard up here where you can click. If you sign in, you'll get a dashboard and it will connect you to your account. But first of all, I want to show you how you can look at the data and explore it in WEkEO. So if you click on data, you'll end up in our data viewer here. And by default, we have 2 products already loaded. But I actually want to look for my sea surface temperature data that would help me with my marine heat wave application that I'm interested in. So when you click layers, you get the catalog here, and you can search by different thematics and by different platforms. So depending on what you already know, you can start looking. If you know you need data from a specific satellite, you can click there and see it. But if you want to look more around different thematics, you can click down here. So I could click at sea surface temperature, for example, here and have a look. Depending on my area of interest for heat waves, I might want to use a regional product. As you can see, there's a number here. But if I want to do something global, I might need a global product. So I'm going to have a little bit of a look there. And you can see here, you've got different types of data. As I was mentioning before, certain products will be more or less useful depending on the application you're interested in. So I'm actually going to look here because I'm quite interested in like a long-term climate perspective at a reprocessed data set. So I click add to map and I'll add the sea surface temperature there. You'll see now that that appears in the viewer, and I can navigate around here. I can look back through time at this data in a visual sense here. So this is one way of looking at the data, but I actually want to get hands-on with the data and maybe do some analysis. So I could download some data. If you look here, click on this button, it will allow you to start subsetting the data to extract the data that you want to work with specifically, and to slim down maybe the time period you're looking over. Oh, sorry, I've just been signed out. Let's go back. There we go. Let's just reload that. So yeah, using this, you can choose an area of interest. So I could choose a box around here, for example, copy it in. I can choose time and dates to stop when start and stop the time series I want to work with, and then I can request the data and I can download it. So I can do this outside of WEkEO from my own computer and download it in my own computer. But what I can also do is look at the API request. So this whole portal that you see here built on the back of the Harmonized Data Access API, which means that you can access this programmatically using the JSON information here through Jupyter Notebooks or any other type of programming language that you can use to manipulate these types of queries. So I can copy this information and then I can use it in other ways, as well as doing it manually through this interface. So remember what this looks like, because we're going to look at it again in a minute. So that's one way of looking at the data. Another way is working with our Jupyter Notebooks. So as Amin said, if you go to your dashboard, here, second, and then you can open up a Jupyter Hub by clicking on here. I already have mine open. It's up here now. I preloaded it this morning. And in this environment, you can start working with the notebooks that we have provided, or you can create your own. When you enter Jupyter Lab, you can create notebooks yourself here. You can also look in the public folder here, which has got a copy of things from our GitHub repository that we have. That's here. So you can go and look at the code directly. If you like, it's stored here for versioning purposes. It's the same thing that's on there. You can copy this then into your own directory, in your working directory here, or you can also use Git to clone it in. If you're familiar with using Git, you can just run the commands through a terminal. If you've ever used command line, this will allow you to clone code from our from our GitHub or from any other Git repository that you're interested in. You can also do basic sort of file operations and things here to bring other data into this environment for you to work. But let's have a look again at the code that we have. If you look on the left here, you'll see the code that we have. Amin's already mentioned that you've got the introductory notebooks and the HDA examples, but we also have various ocean-related examples for you to look at here. There's various different things from Sentinel-3. And if we go back to the ocean case studies, you'll see there's different examples here. Fabrice mentioned the cyanobacteria blooms. There's also some examples of using model data from Cmems. And then we have a marine heatwaves case study, which is the one that I'm going to show you now, and the result of kind of the thinking I was doing about showing an example marine application today. So if you double click on that, it will open and you have this interactive notebook. You can read all the background information here about the application, why we've developed it and what data we've used, what functions we're using in the notebook and why we're using them, so you can follow our thinking about developing this application. And hopefully this would help you to understand and create your own. You can run each of the, so this is these cells here are what we call Markdown, just text written in the notebook, so for you to read. But then you see these cells here that have the little boxes next to them. These are executable cells of code. So this is written in Python, and you can run these by just clicking the play button. I've already pre-run this so that we don't have to spend the time waiting for things to load today. But when you go into the Jupyter environment yourself, you can run all this yourself and go through each step in order to run the example for yourself, and then change it and adapt it as you see fit. The first thing we always do in Python notebooks is import the tools that we need. So that's what this cell is doing. Each of the cells has an explanation in the text around it. So I'm not going to read through the entire notebook for you today, but you can go through and digest in your own time to understand the details. The next step in the notebook, and indeed in all the other notebooks, is that we access the data that we want through the API. So in here, you need to put in your username and password that you get from registering for WEkEO, and this will allow you to generate an API key that gives you the access to the data that I showed you through the viewer by sending that JSON file as a query to the HDA. In various parts here, we're just telling Python where we wanted to put the data and where the queries are that we want to search. So I saved that JSON query that I showed you from the data viewer as a file. You can actually see it in here on the left. If you look at JSON templates, they're all in here, and each one of these is relevant to the different case studies. So we're loading that in. We're just giving some information here on the product ID that we're using. In the first instance in this notebook, we're going to look at some Sentinel-free SLSTR data for an event scale snapshot of what the current situation is with the sea surface temperature. So what's happening now in a certain region of the ocean. So that's the first data we load in here. And that's what these two sections here do, is they actually send a message to the Harness Data Access API to say, the data we want is what's in this JSON file. Please go and find it and bring it into my Jupyter environment for me here. So that's what it's doing here. You can see when you send the query, it runs, it tells you what it's doing, that it's checking, it's submitted the query, and it's bringing the data. This is what it's found for SLSTR for a certain time and region of interest that I've set based on my query that I generated with the data viewer. And I'll scroll down because this is showing that it's all coming into my system and extracting it from its zip files. The next section of the notebook here then is us looking at the data. So we've downloaded some SLSTR data, and now we want to actually investigate what it's showing. So we want to visualize it using plotting libraries that are available in Python. And that's what these cells here do, is that they're actually making a composite image of the SLSTR data. And we haven't visualized it directly in the notebook here. Rather, I've saved it out to file. You've got some options at the top of the script that will allow you to either visualize it in the notebook or to save it out as a figure, so you can download it and use it in other places. There's some benefits and disadvantages to both. Obviously, it's nice to see it on the screen so you can show it, but it also takes up quite a lot of memory, so it's quite efficient if you're doing lots of work in a notebook to save it rather than show it. This is just a feature of the interactive Python environment. If I go back, I can probably show you some of the images. Second. Oh, it's actually not saved out. That's fine. Let's continue with this. So from there, once you've got your SLSTR image to look at, you can then look at a more long-term picture. So I said before, we want to, with marine heatwaves, look at the event scale. So for that, we've got the SLSTR imagery here, but we actually also want to know, like, if we have an event going on right now and we see the water is quite warm from what we think might be the normal temperature, how representative of that is that in history? Is this really more warm than average? We need to look at many years worth of data to see what the normal variability is in the ocean temperature. So that's what this next section does. And for that, we start accessing longer time series of data from Cmems. So this is using the Ostia example that I was showing in the data viewer. And the queries here also have a JSON file, as I showed you before. And we have it over many years. So here we're running from 2008 to 2019. And we send in another query to the harmonized data access. You can see here it is again, accessing all the data. So this is the output from those code cells when I've run them before. And then we start plotting it. So once we've downloaded the data, we can start visualizing it. And in here, we decided to do a little bit of analysis. So there's some conversions that go on here, just taking the data and converting it in terms of units, and then starting to bring it all together into one long time series so that we can actually say, what is the average temperature been over a region of interest in time? In this case, we're looking at an example around the Pacific. You may have heard a few years ago about this big marine blob of heat that happened there. This area suffers from heat waves quite often in history. So we're looking at that area as a good example of marine heat waves in this application. And this is just doing each step, the different bits of analysis that are necessary to extract that time series. And if we scroll down, what we can then see and how we've decided to visualize this data is as an anomaly in time through this climate stripes. Some of you may have seen this is quite a popular way of showing data about temperature change to people at the moment. People have been showing their stripes to see what's happened with temperatures in their region that they live. We can do a similar thing with ocean. So what we have here is the temperature anomaly in this region of interest in the Pacific between 2008 and 2020. And you can see in the red, we've got these years where we've had higher than average sea surface temperatures in the region. And this is kind of what corresponds to our marine heat waves. So this is one way of looking at or answering the question, have there been higher than average temperatures, which might be a marine heat wave in this region? And this is quite a nice visualization. It's simple, people can intuitively understand it quite well. But if we were wanting to look at things in a more technical or scientific way, we could take this same data and apply some more analysis to extract more routinely, more quantitatively, whether there has been marine heat waves. So to do this, we've been using a freely available toolkit from some scientists who've published on this. There's an article here by Hobday al. You can find more information about the toolkit itself and the science that underlies it. And in this part of the code, we're just applying this method that they provided to estimate whether there have been heat waves or not. And in the end result of that is a plot here where you can see you've got the, just scroll down a little bit more, the temperature record in black. And then you've got climatology, so the average over many, many years. And we've set a threshold. So this is generating an index that can give us some information about marine heat waves. And we classify a heat wave as when the temperature goes above this threshold that deviates from the seasonal climatology. So you can see in this year and in this year and in more recent times as well that we've had some times where the temperature has gone above what we would consider reasonably normal and could be classified as a heat wave. And you can see in more recent times as well, we've had further heat wave events. This corresponds to the SLSTR imagery that we looked at to start with. So this is just one example of like the ways that you could work with different data from several different sources in a marine application in Wekio, and how you can take that information, take that data, bring it into a processing environment and do some analysis with it. Of course, you could use many different types of data to support this type of application, or indeed to look at any other type of application. But in principle, the things you might learn from this example, you could apply to many, many different types of the data that we have available and to the different marine applications. So I'm going to stop sharing my screen and just go back to our slides. Okay. So that was a very, very fast tour through this marine application. And of course, the data and information is there in the notebooks for you to go through this at your own time and look in more detail and ask any relevant questions you have through our support desk. We're very happy to help you work through this application in more detail. But just to give you a summary again of what we've shown, you can work with the data in the different Jupyter Hub environment, so you can access the notebooks. There's more information about how to do this online attached to the code, which is on GitHub, but also on our YouTube channel. We have different videos that you can look through to show you how these different notebooks work and follow them again. You can also rewatch this webinar. It will be recorded so you can see it later. And where can you learn more? So this is one marine application example, but we have more courses that we're offering through WEkEO and through the partner organizations. We run marine training at UMETSA, as do our colleagues at Cmems, where we'll look more at different applications and different data sources in much, much more detail than we can cover in a short webinar like today. You're very welcome to ask questions to our help desk about anything here, whether it's about the infrastructure and how it works, or about the data itself, or about what is suitable for the different types of applications. And of course, you can ask some questions now. So with that, I would encourage you to ask your questions through our Q&A in the chat here, and we will do our very best to answer them. Thank you very much for your attention.
Thank you very much for the demonstration, Haley. Before we move on to the Q&A, I will just briefly show you what's coming up in the next webinars. Just looking for my presentation. So we're conducting right now a series of webinars on the Wikio Dias. This is already the 9th one, or the 10th one even. And so what we're the ones that we're at now are really thematic webinars for experts, a little bit more advanced than the thematic webinars for beginners. but both of them, both for the beginners and the experts, you can find on the YouTube channel if you want to have another look at it. And if you're interested in different kinds of applications outside the marine applications, you're also very free to have a look at it at the YouTube channel and learn some more about the Wekio ideas. For now, we're going to take a summer break. We'll be back in September with the webinar on climate applications and then on business applications using the Wekio ideas. So you will receive automatically an invitation for the next webinar on the 9th of September. On climate applications, so we're all looking forward to seeing you there. But in the meanwhile, enjoy your summer holiday and ask us any questions that you have on the webinar today. So let's close this and let's start the Q&A. Oh, I don't have the Q&A showing. Okay. There's one question. Could you elaborate a little bit more about on what services are free and which ones are need to be paid for? Perhaps Amin can answer that, or Fabrice.
Sorry, I was muted. So yes, the access to the catalog and the data, it's free. Once you are registered, you have access to a dashboard and you have access to a Jupyter Hub environment if needed. But if you need computational resources, more resources to launch your codes and store your material, your application, you need to apply for a pay plan. Okay, so the first step, you can register and have access to all the catalog. You can download the data, play with the data through the Jupyter Hub in your dashboard. But then, if you need more resources, CPU, GPU, or memory, etc., you need to apply to a pay plan.
Okay, thank you, Fabrice. We have you ever a next question, which is more for Haley, I believe. Pawan has a question about visualizing algal blooms, the best, and is looking for the best resolution and classification methods.
Yeah, I can definitely answer this one. This was actually one of the topics of my PhD, so I'm always very interested in discussing this topic. So algal blooms are one of the, I guess, marine applications where you might want to use multiple data sources depending on what you're looking at, similar to the marine heat waves, in fact. So they're often at event scale. So you might want one of the level 1 or level 2 data sources from the satellites to look at the kind of highest spatial resolution immediate data you've got on an event. So if you've got a bloom happening off the coast right now, you might want to look particularly at, say, Sentinel-3. If you look at the cyanobacteria bloom example in the Jupyter lab that we provide, that uses Sentinel-3 to show a particular image of a cyanobacteria bloom on a certain day. So that's one way. It's at about 300-meter resolution. You get images every day to maybe more than one a day, depending on where you are in the world, but usually on a daily kind of scale. So it's quite good for looking at these events, event scale things like harmful algal blooms, for example. It also has quite good spatial spectral resolution. So if you wanted to look, for example, at whether it was a different type of algae, you might be able to get some information out of the high spectral resolution from Sentinel-3. If it's quite a small bloom, say in a very near coastal environment, you may also want to have a look at some of the Sentinel-2 data that we have available. Sentinel-2 is not really, it's more of a land sensor than an ocean sensor, but for some big blooms near the coast, as in big as in like high biomass or something like that, you can use Sentinel-2 quite effectively to pick some of these up. That's a kind of growing area of research, so you can use the Sentinel-2 data for that. and that would help you, but it doesn't have quite the same spectral resolution. So you might want to use the two together to get some of the information suitable for you. Similarly, if you wanted to look at blooms happening in an area over a long time period, there's some new products, particularly from Cmems, that are looking at higher resolution, longer time series for things like chlorophyll, where you could see if you've got high levels of chlorophyll associated with blooms over many, many years. So you might want to use all three different data sources, depending on what the particular focus is for your application. Hopefully that answers your question. If you want to talk more, I'd be very happy to.
Well, I guess if you have any more questions, you can always reach out to the Wikio user support and have an offline chat with Haley about this. Okay, great. We have, at the moment, no questions that are for the entire audience.
Yes, Anne-Catherine, we have a question on the hackathon. I can answer that. Sure. Yeah, okay. So a question from Alice Dejoux. Have you ever proposed an access to Wikio and services for an hackathon? Yes, we did already. We participate to IE4EO challenges. We organized in a few years ago a hackathon with different services hosted on the WEkEO platform. So, and we plan to organize a new edition, perhaps by the end of this year or next year, a real WEkEO hackathon. But we are ready to propose the access to this platform for this kind of event, and in the same topic, we are discussing with some teachers to share with us, share with them the platform and practical exercises for their students. So we are involved in this kind of events or sharing knowledge through hackathons or through educational material. Don't hesitate to contact us and to prepare your event. I see the Ocean Hackathon, so don't hesitate.
Thank you very much, Fabrice. I believe we have one more question. For research purposes, can the code shared today be used, and how do people need to reference it?
I can maybe answer this one. Yes, I mean, please do use this code. It's been written and licensed as such that it's freely and openly available for you to work with as you like. It's nice if you can put some kind of citation to say that you have used it, particularly as well to let us know that you're using it. For us, it's really useful to know where people are using the information we put out there. It helps us to see what we've done, if it's right and suitable for purpose, and to show that, you know, what we're doing here for the webinars and writing code is worth it for the user community. So I think in terms of referencing, it would depend on exactly the type of referencing system you're using, but you can certainly link back to the GitHub to reference it. I mean, it's there in Git as a management system. So even if we increment the different variants of it, you'll find that the version you used is maintained through our Git version control. So that's there. And yeah, if you let us know through our support email that you're using it, that would be brilliant. Thank you.
Thank you, Haley. At the moment, I don't see any other questions anymore. But as always, if you do have any questions left, or you come up with something after this webinar, you can always email us at support@wekeo.eu. You can rewatch the webinar on YouTube, or you can follow us on Twitter and also attend the next webinar in September. So thank you all very much for attending. Thank you to the speakers for their presentations and their demonstrations, and wishing you all a very nice summer. Bye.
Bye. Thank you, Anne-Catherine.
Thank you. Bye-bye.
Thank you, Hailey. Bye. Bye.